Well, hello, ladies and gentlemen. This is your well-rounded math teacher, Mr. Picard. We're on Unit 9, Video 4, solving rational equations, and that's our learning target. You can solve rational equations. Here's a little real-world problem. A music device or a music download service advertises downloads for $1 per song. The service also charges a monthly access fee of $15. If a customer downloads songs in 1 month, the bill in dollars will be the actual cost per song is, well, cost per song is $1, but you have this $15 to begin with. So 15 plus however many songs you download. How much is each song going to cost? Well, the $15 plus $1 for each song. And then you have to divide that by the number of songs that you purchase, and that'll be the cost per song. So it says this, number 1 here, find how many songs a person would need to download to make the actual cost per song $1.25. So here's the cost per song, 15 plus x, all over x, equals $1.25. Now this is what we call a rational equation. Because of this side right over here, we have a fraction or a ratio in our equation. Now what we usually like to do is get rid of the denominators. And to get rid of the denominator here, x, I'm going to multiply both sides by x. And this is one tactic for solving rational expressions. I'm going to show you a different one that you might like a little bit better. But anyway, the x's cancel out and I get 15 plus x equals $1.25 x. And I'm going to get all my x's on one side, so I'm going to subtract x from both sides, and I get 15 equals, that's 1x, so 125 minus negative 1, or plus a negative 1, sorry, is a 0.25x. And finally, just to solve for x, I'm going to divide both sides by 0.25, and x equals this. If you buy 60 songs, your songs will end up being $1.25 a piece. So our first little work with rational equations. Here we go, rational equation. Any equation that contains one or more rational expressions or ratios. Well, we just had that last one. I guess another way to look at one may be, how about like 5 over x plus 3 over 2x equals 1/2. This is an example of a rational equation that we will be solving. And you can notice this, we have denominators. Usually when we're adding expressions, we need a common denominator. Well, I'm going to show you how we're going to use a least common denominator to solve these equations. Now, Miss Meyer, she does it a little bit different way, and I think her video's up too, so you can watch mine, see if you like it the way I solve them, or you can check out one of her videos in Schoology. Anyway, another example one, 3 over x plus 2, we'll just say plus 5 equals x over x minus 2. Now the difference between these two equations, they're both rational equations, but here all my denominators are one term or a monomial. Here we're working with two terms, so we might get into some factoring a little bit in order to get a least common denominator. Just like we did in the last section, or 2 sections ago, when we're adding and subtracting rational expressions. Using common multiples or common denominators to solve rational equations, you will eliminate the denominators. You can do this by multiplying both sides of the equation by the least common multiple of the denominators. Least common multiple of the denominators is then called the least common denominator. Now, this method is the method Ms. Meyer uses, and it pretty much works out the same way I do it, just a little bit different. So I'm going to show you my way. Here we go. First, we need a least common denominator. It kind of follows this a little bit, except for number 2, multiply every term by the least common denominator. We're just going to get a least common denominator for all the terms. So, looking at this, least common denominator. Look at the numbers. Now these are all monomials, so it's a little bit easier. I have a 5 here, 5x, and an x. I'm going to need a least common denominator of 5. That 1 5 will cover a factor of 5 here and here. And we're also going to need an x. We have an x here and here, so we need at least one x. If there was an x squared in one of these, then we'd need an x squared to cover that. So the way I do it is this. Okay, first of all, 1/5. Okay, I need a common denominator of 5x. So I'm going to have to multiply top and bottom by x here. Minus the next term, 2 all over 5x. Well, we already have a common denominator of 5x here, so we don't have to multiply that by anything. Equals 1 over x. Well, we already have an x, but I'm missing the 5, so I'm going to have to multiply by 5 over 5. Okay, what I end up with is, here I'd end up with x all over 5x minus 2 all over 5x equals 5 all over 5x. So really what we have to do is this. As soon as you get a common denominator in each one of them, you can kind of cancel that out. Because the answer is going to come from adding these two together and then setting it equal to the 5. That's how I solve these rational equations. So you end up with x minus 2 equals 5. I'm going to add 2 to both sides, and I'm going to get x equals 7. X equals 7. And that's my answer. You should check your answer every time to make sure it works. Sometimes we get answers and they don't work, and that does happen once in a while, but most of the time when you get an answer it should work. So let's plug it in and see what we get here. I'll go black here. So we're going to end up with this. 1 over 5 minus 2 all over 5 times 7 equals 1/7. So it's 1/5 minus 2 over 35 equals 1/7. Okay. Common denominator, I'm going to have to multiply top and bottom by 7 here to get 35. So I get 7 over 35 minus 2 over 35. And that's equal to, well, it is equal to 1/7. But 7 minus 2 is 5. And 5 all over 35 is equal to, if you reduce it, 1/7. So my answer of x equals 7 does work. And that's basically how I do it. Get a common denominator. Once you get that common denominator, you can cancel it out and just solve the equation that is in the numerator right here. And this is just one way to do it, okay? But this is the way I'm going to show you how to do it. Okay. Okay. So we got x minus 3 over 2x plus 9 over x, and then you have this 2 over here. That's the same as 2 over 1. Okay, starting this problem over. We are working with x minus 3 over 2x. Right here. plus 9 over x equals 2, and that's 2 over 1. We need the least common denominator. Just looking at the numbers first, I have a 2 here. It's just 1 and 1, so my least common denominator is going to have a 2. And you can see I have 1x here and I have 1x here. 1x will cover that. So my least common denominator is 2x. So I'm going to take x minus 3 all over 2x plus 9 all over x equals 2 all over 1. And start breaking that down and getting a least common denominator. So I already have a 2x here, so I'm good. Here I'm going to have to multiply by 2 over 2. Over here, I just have the 1. So I'm going to have to multiply by the whole thing, which is 2x in this case. So I end up with x minus 3 all over 2x plus 9 times 2 is 18 all over 2x equals 2 times 2 is 4. That's 4x all over 2x. So you can see right here, I have a common denominator. I can go ahead and then cancel out my common denominator and solve x minus 3 plus 18 equals 4x. Okay, what we got here? Let's go with a little shade of green. So, this is going to give me 15. X plus 15 equals 4x. I would subtract x from both sides. And that's going to give me this. 15 equals 3x. And you can see if you divide both sides by 3, x is going to equal 5. Okay. We've got to make sure that that answer actually works in our original equation over here. So plugging 5 in for x, I'm going to get 5 minus 3 over 2 times 5 plus 9 over 5 equals, well, it equals 2. So I'm going to add the 2 over here together, and it should equal 2. I end up with 5 minus 3 is 2, or 2 over 10, plus 9 over 5. And I want this to equal 2 eventually. Common denominator, it would be 10, but I noticed this. 2/10 is the same as 1/5. Reduce it down. This doesn't work all the time, but it's kind of a nice little shortcut. And then I end up with 1 plus 9, or 10 over 5. And yes, that is equal to 2. So our answer is x equals 5. Okay, let's go on to the next one. And I'm going to show you guys something here. You should be aware of a little bit. It's not a huge deal. It's going to be something more that we work with in rational inequalities, okay? And that's the denominator, okay? First of all, we have 28 here, so we're going to have 28. Z plus 2 and a factor of 4. Anyway, looking at the denominators, you cannot divide by 0. So we have to look at this right here, the z plus 2. Z plus 2 cannot equal 0. What would make z plus 2 equal 0? Well, if you subtract 2 from each side, you get z is equal to negative 2. So basically, if we do get an answer of negative 2, it's going to make this second fraction here undefined. So we couldn't have an answer of negative 2. So you got to keep that in mind. It's what we call a constraint. Anyway, so we usually find those first. I didn't on the first two because I just wanted to get used to solving rational equations, but we'll keep this in mind. We'll just push this over to the side right over here. Just knowing that z can equal negative 2 because it makes this bad boy undefined. And therefore it couldn't be part of our solution to our equation. Anyway, let's get back to least common denominator. Now 28 is just 4 times 7. So I'm going to need one factor of 4 for these two 4s and a factor of 7. I don't need a factor of 2 because that z plus 2, that is all one factor. You can't break that down. So just for the numbers, 28 and 4, we need a least common denominator of 28. 28 divides into 28 and 4 divides into 28, so that covers both of those numbers. We also need a z plus 2. That binomial, I can't just pull that 2 apart from the z because it's z plus 2. It's part of that expression. Anyway, so I have 9 over 28, and I have a 28 in the denominator already. I need to multiply top and bottom by z plus 2. Okay? Plus 3 all over z plus 2. Okay, we got that right there. Well, we have the z plus 2 there, but we need the 28. So I'm going to have to multiply by 28 over 28. Equals 3/4. Okay, first of all, in order to get to 28, I'm going to have to multiply by 7 over 7. Right here, 7 times 4 is a 28, which we want for our least common denominator. I'm also going to have to multiply by a z plus 2, because we don't have that in this denominator. And what we end up with is this. I'm going to leave my denominator as 28 times z plus 2 for all of them. But I do have to multiply what's in the numerator. We're going to have to use the distributive property there. 9z plus 18 plus our next fraction here. I have the 28 right here and the z plus 2 all over, well, 3 times 28. What is 3 times 20? I think it's 84 if you do it with a calculator. Equals, okay, 4 times 7 is 28. So I'm going to have 28 times z plus 2. 3 times 7 is 21. So I'm going to take 21 and multiply it by the z plus 2 using the distributive property. And I end up with 21z plus 42. And there it is. It's a lot of work. But we have a common denominator. So basically, my solution is going to come from adding the numerator and setting it equal to the numerator on this side. So that's the main thing. And we can go ahead and cancel out our denominators and solve. What do we got? First of all, 18 plus the 84, that's going to give me 9z plus 102 equals 21z plus 42. Okay. So getting all my z's on one side, I'm going to subtract 9z. What do I end up with? 102 equals 12z plus 42. Subtracting 42 from both sides, I get 60 equals 12z. And once again, dividing both sides by 12, I get z equals 5 in this case. Okay? Z equals 5. So let's go back up here. Z cannot equal -2, so we're fine there. So our solution, z equals 5, I should go ahead and plug it back into this equation right here and make sure it works. I'll let you guys try that one. It works out nicely. You should get a common denominator of 28, and it ends up working. So let's go to number 5 now. Ooh, it's tough working with that backdrop. So let's do this. You guys, well, first of all, the only restriction we have on x, constraint, is right here. We have a variable in the denominator. The 6 and the 2 have no variables with them, so those don't tell us what we can't have for a solution for x. Anyway, take the x minus 2, set it equals 0, because we don't want 0. And when we add 2 to both sides, I get x equals 2. So what that means is x cannot equal 2. So if we get an answer of 2, that would be no solution for this particular equation then. Let's jump into least common denominator now. Okay, remember, I'm not working with this -2. That's part of that factor. I'm going to need a factor of x minus 2, but usually you work with the constants or the numbers first. If you were working with 2 and 6, what would you say is your least common denominator? Well, 2 divides into 6. That's 2 times 3. So I'd say 6 is my least common denominator. Also, I need a factor of x minus 2. So now we can go ahead and solve this bad boy. 5 over 6, we're going to have to multiply that by, well, we already got the 6 covered. We're going to have to multiply it by x minus 2 over x minus 2. Plus, we got 2 all over x minus 2, right? The only thing we're missing, we already got the x minus 2 in the denominator sign. Now I need to multiply by 6 over 6 equals 1/2. Okay. Now, to get 6, first of all, I'm going to have to multiply denominator by 3. Okay? 3 times 2 is 6 here, and that's good. And then we need the x minus 2 also. Okay? So let's do some multiplying. My denominator is 6 times x minus 2 for this first fraction right here. And I'm going to distribute the 5 through here and get 5x minus 10 plus my next fraction or ratio is going to be same thing in the denominator, 6 times x minus 2 all over, well, 2 times 6 is just 12 equals, okay, a little work here first of all. 1 times 3 is just 3, so it's 3 times x minus 2, and that's going to give me 3x minus 6 all over 6 times x minus 2. Beautiful. So what does that mean? I have a common denominator all the way through. The real equation I have to solve is right on top. -10 plus the 12, all on this left-hand side of the equal sign. That's going to give me 5x plus 2 equals 3x minus 6. And now it's just a simple equation that you guys have been solving for quite a while. I'm going to subtract 3x from both sides. How about we subtract the 2 right away also? So these cancel out and these cancel out. I'm left with 2x equals -8. So x equals, dividing both sides by 2, -4. So let's go back up here. We got x equals -4. And we can have that solution because we're just saying x could not equal 2. Let's plug it in to make sure that 4 works though. I'm going to get rid of this right here. You can pause it and go back and look at it if you wanted to. 5 over 6 plus 2 all over -4 minus 2 equals 1/2. And we get 5 over 6 plus 2 all over -6 equals 1/2. Well, that's the same as this right here, 5 over 6. The negative, I can just put in the numerator and say that's plus -2 all over 6. 5 plus a -2 here is going to be 3 over 6, and that is definitely equal to your 1/2. So -4 works. -4 is our solution. Awesome sauce. Okay, let's do another one here, number 6. Hopefully this helps you guys out. All these examples. 7 over 12 plus 9 over x minus 4 plus, or equals, I'm sorry, 55 over 48. Okay. Any restrictions on x? Yes. X plus, or I'm sorry, minus 4 cannot equal 0. So adding 4 to both sides, what does that mean? X cannot equal 4. If it does, it makes this fraction right here undefined. Therefore, we can't use it as a solution. If our solution was 4, our answer would be no solution. Okay? It's what we call a constraint on our system. Now, It's not so important for these equations. We just can't use that as a solution. If we do get 4 for an answer, it's really important for when we get to inequalities, rational inequalities, and that's a couple sections from now. So it's good to know that x can't equal 4. Anyway, least common denominator. Okay, look at the 48 and the 12. We know we're going to need a factor of x minus 4. 12 divides into 48 4 times. So I'm going to say my least common denominator is going to be 48 and that x minus 4. So let's multiply it up. We got 7 over 12. To get the 48, I'm going to have to multiply first by 4 over 4. And then, of course, we need that x minus 4. Okay? We're just trying to get a common denominator for all our fractions. And then we can solve. Plus 9 all over x minus 4. We already got the x minus 4, so we just need to multiply by 48 over 48. Equals 55 over 48. And we're going to multiply here. We already got the 48 covered by x minus 4 over x minus 4. Okay, so clean it up. You can cancel out your denominator out because we're going to have a common denominator all the way through. 4 times 12 is 48, and that x minus 4. I'm not going to multiply that through. Here we go. 7 times 4 is 28. Now I'm going to take that 28, multiply it by the x minus 4. Use the distributive property there. And we are going to get 28x. What is 4 times 28? I think it's 112. Minus 112. Plus. That was this fraction right here. Our next one. Denominator is going to be 48. Right here. Times the x minus 4. I'm going to leave it like that. I'm going to multiply 9 times 48, and that's 432 on my calculator. Distributing the numerator here, I'm going to get 5 times x is 55x, and then, 55 times x is 55x. And then 55 times the negative 4, that's negative 220, all over the 48 times the x minus 4. Okay. Let's get down to business. My denominators are all the same. So basically I just solved the numerator now. It's going to be 20 on this side here. Being careful with what numbers we can add. When I get 28x, the negative 112 plus the 432 is going to give me 320. Positive 320 equals 55x minus 220. Okay, I'm going to subtract 28x from both sides. Get all my variables on one side. And that's going to give me 27x minus 220. 55 minus 28 is 27. I still have the 320 on this side. I'm going to add, what do we got here? Oops. I'm going to add 220 to both sides. And I'm going to get 540 equals 27x. Finally, dividing both sides by 27 on your calculator, you should get x equals, I think it's 20. X equals 20. And that's my answer. Now, our constraint up here, it could not equal 4. So, x can equal 20. And you can plug it in right here and get a common denominator, and you're going to see that it does work. Okay, let's go to the last problem. It's a little bit different, not much. Working with rational equations, but a lovely shade of blue. Okay. Okay. We're going to get the least common denominator in a minute. Are there any constraints? Are there any restrictions on x, basically? What can x not equal? Well, I have an x in the denominator here. No matter what, that denominator cannot equal 0. 3 minus x cannot equal 0. I'm going to add x this time to both sides because I have a negative x right here. And I get 3 equals x. Now what does that mean? Basically, your constraint is 3 cannot equal x. So you can't have an answer of 3. If it does, it makes this fraction right here undefined, therefore blowing up your problem, and you'd have no solution. Okay? Or maybe you get 2 answers. Sometimes we get quadratics. We have to solve those quadratics and we get 2 answers. One answer works and one answer doesn't. That also happens. So, least common denominator. Between the numbers, okay, this is a factor here. I can't pull that 3 out of there. 24 and 4 divides into 24 evenly. So I'm going to say my least common denominator is 24. And we need that 3 minus x there. So, setting this up, 5 over 24, we need 3 minus x. That's the only thing we're missing for this denominator. 3 minus x. Okay. That takes care of the 5 over 24. Plus 2 all over 3 minus x. Well, the only thing we need here is a 24, so I'm going to multiply by 24 over 24. Equals 1/4. Okay. First of all, we got to get that 4 to be the 24. So I'm going to multiply by 6 over 6. And we also need, obviously, a factor of 3 minus x in order to get a common denominator for all 3 of my fractions in this equation. Lovely little background music here for us. Incredible. So, right here, working with this bad boy, let's distribute the 5 through. We're going to get 15 minus 5x all over 24 times 3 minus x. I'm not even going to multiply that out in the denominator. Plus, what do we get from this fraction? Denominator is the same. We got 24 times the 3 minus x. 2 times 24 is 48 equals, okay, 4 times 6, 24 in my denominator, 3 minus x, all over. 1 times 6 is 6, so that's going to be 6 times 3 minus, x. 3 times 6, right here, is 18, and the negative 6x. Okay. Don't mind the bells ringing. We have a common denominator for all 3 of our fractions. I can go ahead and then cross that out and start solving. I'm going to have a negative 5x here. 48 and 15, positive 15, plus a 48 is going to give me 63 equals 18 minus 6x. Okay, we have 2 negatives for our x values. I'm just going to add 6x to both sides. These cancel out. Still have 18 over here. This adds up to just x, so it's x plus 63 equals 18. Simply subtract 63 from both sides, and you get x equals negative 45. And that's our answer. Our constraint up here, what x cannot equal, was 3. So we definitely can have x equals 45 and negative 45, sorry. This is what I get for an answer. You should always check your answers. I know I haven't been doing all of them. I'm trying to save you guys a little bit of time on this video. But I'm going to do this one, just in case negative 45 is not a solution. So we got 5 over 24 plus 2 all over 3 minus, that's negative, minus right here, negative 45 equals 1/4. Okay, basically we're working on this side right here. This is 5 over 24 plus 2 all over 48. Okay, that works. 24 goes into 48 twice. So I'm going to multiply it. Now I could, look at this, I could reduce 48, 2 over 48 down to 1 over 24, that'd probably be easier. but I'm just gonna get a common denominator here, because you're not always gonna be able to reduce. So 2 over 2, that's 10 over 48, plus 2 over 48, and that's equal to 12 over 48. Guess what that reduces down to? Yeah, 1/4. Bomb! We got the bomb here. Oh man, the answer's awesome. Incredible. So that's it. That's a lot going on. We have another day of solving rational equations tomorrow. This is our first little day with it. Enjoy your worksheet. See if you have any questions. Circle where you have questions and come in and see me tomorrow, and we'll work it out. Okay. Peace out, Girl Scout.